Hi, this is Lori, and this is my homework for Paul McWhorter's Pico W course, lesson number 17. In this lesson, we're going to use a momentary switch or a button and pull up resistors to turn an LED on and off. Here's the circuit I'll use for this lesson. We'll have our Pico with our LED current limiting resistor connected back to GPIO pin, and then we'll connect our button on one side to ground and on the other side back to a GPIO pin. So pull down and pull up resistors are used to stop sort of a floating voltage condition when there's no input to our GPIO pin. And we use the pull down or pull up resistor to ensure that the pin is in a low or high state when there isn't an input to our GPIO pin. And I found this diagram pretty good for remembering how this works. So for the pull down resistor, that one's connected to ground, then to the pin, and then to our switch, which is connected to power. And when we use a pull up, it's the opposite. Our resistor is connected into the power, then to the pin, then our switch is connected to ground. Now we can do that by actually putting resistors on our circuit, but we can also use internal pull down and pull up resistors in our Pico with code. So this is the code here for example, to set up a button pin with a pull down resistor, and here's the code to set up the pin with a pull up. So we don't have to put the resistor physically into our circuit. The Pico will do that for us. And I kind of drew this conceptual diagram just to kind of make it clear to me how these things get set up. So for a pull down, we'd connect one side of our button to power, just like we're seeing up here. Then we'll go to our pin, and then inside the Pico will provide a resistor and connect it into ground, just as shown here for the pull down resistor. And then for the pull up, which we're going to use in this homework, we connect our button, one side of our button to ground, as is shown here, back to our pin, and inside the Pico, it'll connect through a resistor to power. I've done this sort of lesson before with Paul in some of his other series, and so I have three different ways that I would handle a button and turning on an LED, and I think this first one here is probably the most basic and simplest, but it does have some flaws. So we'll go ahead and import our modules, and we'll set up our button pin with our pull-up resistor and our LED here as well on 15, so 12 and 15, and then we'll put our while true loop. And then we're going to check to see what the value of the button is, and if it's 0, meaning that we press the button, then we'll toggle the LED on and off. And we'll need to sleep some because we'll need to debounce this circuit. There's some floating voltage when you press buttons, and so you do need to have some sleep in here so you don't register too many buttons. And then we'll use try and accept so that we can make sure we turn the LED off using Control-C. Well, let's go ahead and run this one. All right, and I'm going to come in here and press the button, and it goes on, and I press it again, it goes off. And if you mess with the amount of sleep you give, you can find that there's some settings where if you go too little sleep, it won't work very well. Now, the flaw with this one is that if I press and hold, you can see it's going to flash. And I need to let go because I'm exceeding the sleep time and I'm getting flashing, and so then you kind of don't get the for sure toggle no matter how long you press. So while that will work and you can kind of fine tune it for your own switching speed, it does have that problem. So we'll try the next program to see if we can fix that. And here's my second program that will handle the problem of making sure that if we hold the button, it'll still only turn it on or off once, no matter how long I hold on to that button. And how we'll do that is by having a variable that will track what the value of the button was on the previous round through the while true loop. So we'll initialize button previous to 1, And then we'll read the button and we'll assign that to button current. So that's the current state of the button. And when the button previous was 0, meaning it was pressed on the previous time through the loop, and now it's back to 1 again, in other words, it's not pressed anymore, then we're going to go ahead and toggle the LED. We'll put a little bit of sleep in for debouncing, and then very important is we'll set the previous to the current and go through the loop again. So let's see this one go. So now I'm just going to do quick presses and it seems to work. But now if I hold long, notice I'm pressing down, it's not coming on until I let go. It's not going off until I let go. So that's a pretty satisfying solution, and that works well. Now I've got one more to go. Now the other way that I would handle a button, and I've kind of switched to this, doing some of my own projects, I found using interrupts is a very reliable way to dealing with button presses and having actions happen when you press a button. Now with our simple circuit here where we're just trying to turn on and off an LED, probably don't absolutely need interrupts, but it's something nice to have in your toolbox. So I thought I would share it, and maybe you'll take some time to learn it. But it's definitely an advanced topic, so if you're a beginner, don't need to get into this just to do the homework that Paul gave us, but I thought I would share a little bit about interrupts. So what we've been doing in our previous programs is at some point we read the button and we're sort of polling the button. In other words, we're asking the button, what state are you in now? And then we're going to have some code that says do something else depending on the state of the button. And so that's kind of like a very linear program. And the downside of that is if the program is long enough, then it could be that you might miss a button press because you're busy in some other part of the program and you don't notice that the button has been pressed because you're not at that part of the program. So that's solved by using what we call interrupt functions, and those are kind of pre-set up. And as soon as you activate an interrupt function, in the case of our situation, we're going to use a button. If we press the button, it's going to interrupt the main flow of the program, jump over and do the interrupt code, and then once that's complete, it'll come right back to where it was before and continue in the program. So that's how you can have a reaction to a button and not necessarily potentially miss the button press. Here's the code that I would use to do an interrupt for this project. We'll import the needed modules, and picking up a couple of different sleep functions here to handle my interrupt function and do the debouncing of our button inside the interrupt function. Then we'll need a couple of variables to track the activation of the button and to do some debouncing, so an interrupt flag and a debounce time. Then this is the function that we'll call button handler, and we'll give it the value of my button, which is the button that we set up here. And we're going to make global these two variables so we can use them both inside this function and outside. Then we're going to do a little bit of debouncing, so as long as the difference between the last time and the current time is more than 300 milliseconds, then we're going to say that's a real press of the button, and we'll turn the interrupt flag on to say the button has actually been pressed, and we'll reset the debounce time to the current ticks milliseconds. Then with that, we need to activate this request, and we'll say assign to my button this interrupt request, and it'll be triggered when we rise, when we're getting a rising signal out of our button, and we'll use our button handler function when that happens. Then we'll go into our while true loop, and it's still pretty simple. Once we have that function written, we'll ask, has the interrupt flag been set to 1? Then the button has been pressed. We'll immediately turn it back off again so that we can detect another button press, and we'll just print interrupt detected just to make sure that actually happened, and then we'll toggle the LED, and we'll use try and accept so that we can turn the LED off cleanly. Let's go ahead and run this one. And and we'll press and hold, press and hold, quick presses, and you can see the interrupts being detected here. So it all works, and once you get used to setting these up, I think they're a nice way to go, especially as your program potentially gets more complicated and you want things to happen immediately once you press a button. Well, that's my homework. Thanks for watching.